All right, so in the back of the handout, it talks about something called complex numbers. Now, complex numbers are any number that can be written in A plus BI form. So basically, we have a real component and we have an imaginary component. So for example, this right here, 3 plus 5i. Here's your real component, the 3, and here's the 5i, your imaginary component. All right, so we're going to do some operations with complex numbers on this page, and the directions want you to write your answer in A plus BI form. So all they're really telling you to do is write the real component first and the imaginary component second. And keep in mind, sometimes this could really be a subtraction sign, because if your imaginary component is a negative, right, like if you had 3 plus negative 5i, that's the same thing as 3 minus 5i. So sometimes this is a subtraction sign. All right, so let's get started. So number one, all they really want us to do is to subtract these two complex numbers. So I'm going to there's really a 1 in front of this parenthesis, so if you distribute a 1, nothing within the first parenthesis changes. So I'm going to bring down the 3 plus 5i. Now this is really a negative 1 in front of the second parenthesis, so I'm going to distribute this negative to both terms, giving me negative 8, and then plus 8i, because a negative times a negative is a positive. Okay, so now from here, all I'm going to do is just combine my like terms. So I want to write my real component first. So if I were to combine my 3 and my negative 8, that would give me negative 5. And then if I were to combine my 5i and my 8i, that would give me 13i, so plus 13i. Now if you want to check this in your graphing calculator, you totally can. You can just, remember the I button is just second decimal, so just plug in this expression exactly like you see it, and when you hit enter, you will get this answer. So just stop the video and give it a try. All right, so number two. Number two just takes two complex numbers and they want you to multiply them out. So if we have a binomial times a binomial, let's just double distribute. So we're going to get 1 minus 2i plus 2i minus 4, and then I times I is I squared. Now, if we look over here, whenever you have I to some power, you want to rewrite it with what it's equal to. Now, we know I squared is equal to negative 1. So this I squared right here is equal to negative 1. So when we go to rewrite our expression, we have 1. Now, if you want to combine these, I mean, basically what's going to happen is they're going to just cancel out, right? A negative 2i and a positive 2i cancel each other off. And then if we have a negative 4 times a negative 1, that's going to give us positive 4. And then 1 plus 4 is 5. And again, if you want to check this in your calculator, go for it. You can plug in this original expression and it should give you 5. And I know they said they wanted it in A plus BI form, but isn't this just equivalent to 5 plus 0i? So, we can technically call this a complex number. Okay, number 3 is actually pretty similar to number 2. When you have a squared, it just means you have two of the same things. So we're going to have a binomial times another binomial. All right, so let's just double distribute this out again. So 1 times 1 is 1, and then 1 times negative 6i is negative 6i. Negative 6i times 1 is again negative 6i, and negative 6i times negative 6i would be positive 36 I squared. Now again, remember, I squared is equal to negative 1. So really, if we have a positive 36 times a negative 1, that's going to become a negative 36. Okay, so let's bring down our 1, and then why don't we just combine like terms? Negative 6i and negative 6i would be negative 12i. Okay, so to finish, again, we just have to combine like terms. We just have to combine our 1 minus 36, and if we want to write this in A plus BI form, we're going to write the real component first, so negative 35, and then you can bring down the negative 12i. Okay, number 4. So because it's squared, I'm going to take it and write it out twice. And this time we have a y in there, but that's not a big deal. Okay, so when we double distribute, 2 times 2 is 4. 2 times negative yi would really just be negative 2yi. Okay, again, a negative yi times 2 would be another negative 2yi. Okay, just put the y at the end of the expression. And then negative yi times negative yi would be positive. Well, y times y is y squared, and I times I is I squared. Now, because we know that I squared is equal to negative 1, we know that positive y squared times negative 1 is negative y squared. All right, let's bring everything else down. I'll bring down the 4, and I can combine these to give me negative 4yi. Okay, well, there's nothing else we can combine here, so this is it. Okay, we are all done. Number 5, we're going to double distribute first, so I'm going to take the negative 3 and distribute it to both terms, giving me negative 6, and then plus 12i, and then I'm going to distribute the negative I to both terms, which gives me negative 2i, and then plus 4i squared. Okay, now there's really just a positive 1 in front of this parenthesis, so if you distribute the positive 1, nothing's going to change. You could just bring down the plus 1 and the plus 3i. Alright, so let's take care of that I squared first. I like to get rid of those exponents. So we know that I squared is equal to negative 1. So if we have a 4, positive 4, times a negative 1, that's going to give us negative 4. And I'm just going to bring everything down. We'll combine like terms in the next step. We have a lot to bring down here. Okay, so when we combine our like terms, we are just going to combine, I guess, our whole numbers. So we have a negative 6, a negative 4, and a positive 1, so that's going to give me negative 9. And then when we combine our i's, we'll have a 12i minus a 2i, which is 10i, plus 3i, which is positive 13i. So we have negative 9 plus 13i. And again, if you want to check, just plug this entire original expression into your calculator and hit enter, and your calculator will tell you negative 9 plus 13i. All right, number 6. Now, there's a couple different ways you could start with number 6. You could double distribute out these two parentheses, or if you want, you could distribute the negative I in first and then double distribute. I'm going to actually do that. All right, I'm going to distribute. I'm going to change colors. So we're going to go to blue. So negative I times 2 would be negative 2i, and then negative I times negative I would be positive I squared. Now before I double distribute, I like to just get rid of my exponents if I can. So since we know that I squared is equal to negative 1, I'm just going to replace this I squared here with a negative 1. So now we have negative 2i minus 1. And I know this isn't written in a plus bi form, but I mean, that's okay because we're going to write our final answer in a plus bi form. All right, so let me bring down the 5 plus 6i. All right, so we just have to double distribute and then we're done. So negative 2i times 5 is negative 10i. Negative 2i times 6i is negative 12i squared, right? I times I is I squared. Negative 1 times 5 is negative 5. And negative 1 times 6i is negative 6i. And I know we keep seeing this, but this I squared right here, right? This is equal to negative 1. So if we have a negative 12 times a negative 1, that's going to give us a positive 12. And I'm just going to bring everything else down. Okay, so let's combine our like terms. Let's combine the whole numbers first. 12 minus 5, I guess I'm going to go this way because I'm kind of running out of room, is positive 7. And then negative 10i plus 6i would be, oh, I'm sorry, you know what, look at this. This was a minus 6i, so this should be a minus 6i. Okay, so then negative 10i minus 6i would be negative 16i. At this point, I mean, if you're really getting the hang of this, you might as well try number 7 and number 8 on your own and see how you do, and then you can hit play and check your answers. Okay, so here we have the work for number 7. I'm just going to go through step by step what I did. So I first distributed the I to both terms here, leaving me with this. And then I just double distributed out these two parentheses, leaving me with this here too. And feel free to hit pause if you want to really stop and check your work. All right, so then since I squared is equal to -1, I did -2 times -1 is +2. And really the same thing over here, okay? -12 times -1 is +12. And in that same step, just to save time, I just combined the -18i and the +8i to give me -10i. Okay, so now what I did was, I actually just combined like terms. I now combined the +12 and this +12 to give me +24. And I wanted to get rid of these parentheses here, so I distributed the negative to both terms, giving me -24, and then +10i. And then to finish, I just combined my whole numbers, okay, the real component, to give me -22. And when I combined my imaginary components, that gave me +14i. Okay, so you may have looked at number 8 and said, you know what, I'm going to play the video for this one because we have something new in here, I cubed. Now, if you remember earlier on, I mean, you can rewind if you want, but we did say that I cubed is equal to -I. So if you were to take, I'm going to just write this out for right now as 5 times -I. If you were to multiply 5 and -I, it would really just give you -5i. Okay, and then from here, when something's squared, we're going to do what we've been doing in all the other problems. We're going to write it out twice and double distribute. So we're going to wind up, and remember, put it in one big parenthesis because you want to subtract out this entire expression. Okay, so we're going to wind up with 16 minus 4i minus 4i plus I squared. All right, so let's bring down our -5i. And I'm going to wait to distribute. Let's combine our like terms first. Now, since we know that I squared is equal to -1, I'm going to combine my 16 minus 1 to give me 15. And then I'm also going to combine my -4i and -4i to give me -8i. This one's actually not that bad. Okay, so we'll bring down the -5i, and when I distribute this negative, I'll have a -15 and a +8i. So I'm just going to write my answer. Okay, the -15 is going to come first, and then when I combine the -5i and the +8i, that's going to give me +3i.